In this video, we learn about the second case of the reducible linear coefficient to homogeneous functions. Suppose our differential equation is given by equation 1, then we can rewrite equation 1 in the form of m of xy dx plus n of xy dy, where m of xy is given as ax plus by plus c, and n of xy is given as ex plus fy plus g. Here we have m and n to be linear, but they are not homogeneous. For case 2, if we have e on a is equal to f on b is equal to k, then we are going to use the transformation z is equal to ax plus by. And so when we differentiate z with respect to x, we are going to have a plus b dy dx. So after we are done substituting this transformation into a given differential equation, our resulting differential equation will be a separable differential equation in terms of x and z. With our first question, we have to solve the differential equation x plus 2y plus 3 dx plus 2x plus 4y minus 1 dy is equal to 0. To solve this differential equation, we must first compare our differential equation to equation 1 in order to get the coefficient. And so from equation 1, thus we have m of xy to be x plus 2y plus 3 and n of xy is equal to 2x plus 4y minus 1. We now compute our coefficients, right? So we are going to have a to be equal to 1, b to be equal to 2, and c is equal to 3. And also we have e to be equal to 2, f to be equal to 4, and g to be equal to minus 1. We now compute e on a and f on b. So e on a will be giving us 2 on 1, and f on b will be giving us 4 on 2. And so we are going to have 2, 2. So that's 2 is equal to 2. And so in this case, we have e on a to be equal to f on b. Since a on e is equal to f on b and is equal to 2, we make the transformation z is equal to ax plus by. Thus z is equal to a times x, so that's going to be 1 times x, which is x, plus b times y, so that will be 2y. Now let's differentiate. So the z dx will be giving us 1 plus 2 dy dx. So we are going to make these two transformations, right? Thus our differential equation will be giving us x plus 2y is now z, right? So we are going to have this guy to be z plus 3 dx plus, so now from this side we can factor out 2, right? So we are going to have this to be 2 out x plus 2y, and x plus 2y is z. So we are going to have this guy to be 2 times z. So here is going to be 2 times z, then minus 1 dy. So we need to find dy from this transformation. So from this transformation, dy will be giving us, so we first multiply through by dx, so that's going to be dz is equal to dx plus 2 dy, implying that dy is giving us dz minus dx all divided by 2. So thus we have dz minus dx all divided by 2 is equal to 0. Simplifying this gives 2 out z plus 3 dx plus 2z minus 1 dz minus dx is equal to 0. Simplifying this gives 2z plus 3 dx plus 2z minus 1 dz minus 2z minus 1 dx is equal to 0. We now group like terms, that's terms with dx and terms with dz, and so we're going to have 2z plus 3 minus 2z minus 1 dx plus 2z minus 1 dz is equal to 0. Simplifying gives 2z plus 6 minus 2z plus 1 dx plus 2z minus 1 dz is equal to 0. And so here this term will cancel this term, so you're going to be left with 6 plus 1, which is 7, so that will be 7 dx. So 7 dx plus 2z minus 1 dz is equal to 0. And so we have 2z minus 1 dz is equal to minus 7 dx. Integrating both sides gives integral of 2z minus 1 dz is equal to minus integral of 7 dx. So thus we are going to have z squared minus z is equal to minus 7x plus a constant c. But z is giving us x plus 2y, and so we are going to have x plus 2y squared minus x plus 2y is equal to minus 7x plus c. Simplifying this gives x plus 2y squared, then minus x minus 2y plus 7x is equal to c. And so our final answer will be giving us x plus 2y all squared plus 6x minus 2y is equal to c. With our second question, we have to solve the differential equation x plus y plus 6 dx is equal to x plus y plus 2 dy. We compare our given differential equation to m of xy dx plus n of xy dy. And so here we must have this guy to be 0, thus we must have the right hand side to be 0, and so we need to move this expression to the left hand side. And so we are going to have x plus y plus 6 dx minus x plus y plus 2 dy is equal to 0. Thus we have x plus y plus 6 dx plus minus x minus y minus 2 dy is equal to 0. And so we have our m of xy to be equal to x plus y plus 6 and n of xy to be equal to minus x minus y minus 2. And so our coefficients are a is equal to 1, b is equal to 1, and c is equal to 6. And also for n, we have e to be equal to minus 1, f to be equal to minus 1, and g to be equal to minus 2. Now we compute e on a and f on b. So e on a will be giving us minus 1 on 1, which is minus 1, and f on b will be giving us minus 1 on 1, which is minus 1. Thus e on a is equal to f on b, which is equal to minus 1. And so we are going to use the transformation z is equal to ax plus by. Thus z is equal to x plus y. Now let's compute the z dx. The z dx is giving us 1 plus dy dx, and so we have the z to be equal to dx plus dy. Hence dy is equal to dz minus dx. We now substitute z is equal to x plus y and dy is equal to dz minus dx into a given differential equation. And so we are going to have x plus y is now z, so that's going to be z plus 6 dx plus minus x minus y is equal to minus z. And so this will be minus z minus 2 dy is giving us dz minus dx, and so we're going to have here to be dz minus dx is equal to 0. Let's factor out minus 1 from this term. And so we are going to have z plus 6 dx minus out z plus 2, then dz minus dx is equal to 0. So we now distribute this guy. So we are going to have z plus 6 dx minus z plus 2 dz. So here we're going to have minus 1 times minus 1, which will be plus. So that will be z plus 2 dx is equal to 0. So we now group terms with dx and terms with dz. Thus we have z plus 6, then plus z plus 2, all dx minus z plus 2 dz. Simplifying this term, we are going to have 2z plus 8 dx minus z plus 2 dz is equal to 0. And so we can factor 2 from the first term, so that will be 2 out z plus 4 ds. Then we move the second term to the right hand side, so that will be z plus 2 dz. We now separate variables, and so we're going to have 2 dx is equal to z plus 2 on z plus 4 dz. So we can now integrate both sides, so that will be integral of 2 dz is equal to integral of z plus 2 on z plus 4 dz. For the integral 2 dx, we are going to have 2x plus a constant, say c1. And also for the integral z plus 2 on z plus 4 dz, we are going to use u substitution. And so we are going to let u to be equal to z plus 4. So which implies that du dz is equal to 1. Thus du is equal to dz. Also, we have z to be equal to u minus 4. Thus, our integral will be giving us, now z is now defined to be u minus 4. And so we are going to have integral of u minus 4, then plus 2, divided by z plus 4 is now defined as u. So this guy is going to be u. And dz is equal to du, and so this will be du. Now let's simplify. So you're going to have integral of u minus 2 on u du, which is the same as integral on u minus 2 on u du. Thus we have integral of 1 minus 2 on u du. Hence, our integral is given as u minus 2 ln of u plus a constant, say c2. But u is given as z plus 4. And so we are going to have our final answer to be equal to z plus 4 minus 2 ln of z plus 4 plus a constant, c2. Thus, our integral will be given as 2x is equal to z plus 4 minus 2 ln of z plus 4 plus a constant c. But z is equal to x plus y. And so our answer will be equal to 2x is equal to x plus y plus 4 minus 2 ln of x plus y plus 4 plus a constant c. Hence, our general solution is x minus y minus 4 minus 2 ln of x plus y plus 4 is equal to a constant c.